The second type of functions we're going to look at are quadratic functions. And those are functions that are polynomials of degree 2 now. Like linear functions are polynomials of degree 1. Now polynomials of degree 2. And we're going to start with the most basic example. Let's say a is 1, but the other coefficients are both 0. So essentially you've got f of x, which is x squared. And I want to look at its graph. So well, maybe I'll choose a few points. Right? Once again, maybe I can even write y equals f of x equals x squared. Just to remind myself that this is the column for the y values or the y coordinates of my points. If I have x is minus 2, it's going to be squared. So it's going to be, the y value is going to be 4. Minus 1, 1, because when you square minus 1, you get 1, 0, 0, 1, 1, 2, 4. And maybe in between, right? If you want to, square root of 2, 2. Here we go. So we've got many points here. Okay, let's try to illustrate this on a graph. So notice how my scaling is a little bit different along the x and the y axis so that I can accommodate all my points. Right, this should be 4 up there if I want to include all my points. So this is why it's a bit more compressed along the y axis. So 0, 0, 1, 1, 2, 4, but also minus 1, 1, minus 2, 4. And of course, in between, there's root of 2. Root of 2 is 1.4, so 1.42 would be somewhere here. If I would link all the possible points, okay, that I could create with a curve, it would look like this. And it's really flat here at the origin. So I always have students going like this. That's not it, okay? It's actually flat here at what we call the vertex of this curve. So this is what the curve looks like. Okay, we're going to look now at another example. We're going to look at f of x is minus x squared. So what if I hit the expression with a minus sign? Okay, well, the only difference, if I do this, okay, if I pick the same numbers as before, okay, the only difference is that I'll have the same numbers but hit with a negative sign, right? And it's minus x squared, so I'll have minus 4, minus 1, 0, minus 1, minus root of 2, and minus 4. So if I graph this function, okay, 0, 0, 1, minus 1, 2, 4, minus 4 actually, minus 1, 1. So I'm sorry, I should have put, let me change this. That's better. 2, minus 2, minus 4. So all these points that would be linked with by this curve. So it's basically the previous curve but flipped around, okay, across the x-axis. So we see that having a negative in front of our x squared, it makes the curve what we call it concave down. So this curve here, this is something we use a lot in calculus. We say that the curve here is concave down, okay. And essentially, you know, if I had like a minus 2, it would still be concave down. So as soon as the coefficient in front of my x is negative, it's going to be, I'm going to generate negative numbers, okay, in my range. So I'll have a curve that's concave down. So this is for all a values, like a as in the function, remember, it's ax squared plus bx plus c. So there's concave down when a is negative. And over here, it's concave up if a is positive. And this is a feature that the graphs of quadratics will retain even if I add a bx plus c, okay? So the concavity is only going to be affected by the a value. So let's draw another one. Now we're gonna take the first expression, so x squared we had before, or actually we're not gonna keep the previous one, minus x, and we're gonna add 1 to it. So it's minus x squared plus 1. Okay, so let me draw x and, well, not draw, but in a table, compute x and f of x values. Okay, basically we square and we add 1. So minus 2 squared is 4, and sorry, minus 4, and we add 1, minus 3. Minus 1, if I square it, it's 1, I add 1, 0. 0, you square it 0, you add 1, 1. I could take like under values, like root of 2, you square it, minus 2. Well, square it, it's 2, so minus x squared is minus 2 plus 1 is minus 1. And 2, you square it, 4. Minus 4 plus 1 is minus 3. Okay. Then I can try to come up with what that curve is. So let's include all those points. Okay. So what do I have? Minus 2, minus 3. So I'm down here. Minus 1, 0. Here. 0, 1. Probably also 1, 0. You can check. Root of 2, minus 1. So somewhere here. 2 minus 3 down there, and if I link these points, it looks like this. Now there's something I want you to observe, is that this, basically we knew its graph, right? It looked like this. Okay. And then what did we do? We added 1 to every single y coordinate. Okay, so for example, previously we had a point here which was on this curve minus 1, minus 1. Okay, now when we add 1 to the y coordinate, it becomes 0, and that's indeed a point on our curve. So essentially, we added 1 to every coordinate. Okay, we did plus 1 to all of those. And that's how we got the y values for our current f function. So essentially, adding a constant to a previous function will just shift up or down, depending if the function is the constant is positive or negative. We'll just shift the graph up or down. So let's actually add this as a comment. So the graph of x squared plus k is the graph of x squared shifted, or f of x equals x squared, shifted by k units vertically, up if k is positive, down if k is negative. Okay, so if I have, I don't know, f of x is x squared minus 1, you see it would be the graph of x squared, which looks like this, but you shift everything 1 unit down, so it would be downwards here, something like this. So this would be y equals x squared minus 1. That would be the curve. Okay. So similarly, if and the function is still going to be concave up. Similarly, if you have f of x, which is minus x squared plus k, where you're going to shift the graph of minus x squared k units vertically. Here we go. And I've illustrated this with an example where I have like minus x squared plus 2. It would be concave down, but it would be a little bit higher than the graph of minus x squared. Maybe one last comment is that these curves are called parabolas. So all the graphs of quadratics are those of parabolas, and these points here, right? Those are called the vertex, okay, of the curves. Okay, so it's the highest or the lowest point. Okay, those curves are super important in physics, or if you want to shoot a rocket or throw a ball, because when you throw an object in the air, okay, the trajectory is a parabola. Okay, so those are pretty important curves. This is one of many possible applications of parabolas, but you'll find them a lot in physics for that reason, especially in mechanics.